cvmc EC Unit 2 Complex Integration. Lesson 13. Problem 51. Using residue theorem, evaluate into over C z cos z by z minus pi by 2 whole cube dz, where C such that mod z minus 1 is equal to 1. Solution. According to given problem, f of z is equal to z cos z by z minus pi by 2 whole cube. Poles of f of z using equating denominator 0, z is equal to pi by 2, z is equal to pi by 2. Point form pi by 2 0, real part pi by 2, imaginary part 0. Mod z minus 1 is equal to 1 is a circle with the center C10, radius r is equal to 1, CP distance between 2 points 1 minus pi by 2 minus 1 whole square plus 0 minus 0 whole square is equal to square root cancel pi by 2 minus 1 pi minus 2 by 2 3.14 minus 2 by 2 1.14 by 2 0.57 less than 1. CP less than R implies P lies inside the circle mod z minus 1 is equal to 1. Z cos z by z minus pi by 2 whole cube cancel, limit z tends to pi by 2 1 by 2, z cos z derivative first time apply UV formula, z into cos z derivative minus sin z plus cos z into z derivative 1 by 2 constant, limit z tends to pi by 2 d by dz, simplify it, minus z sin z plus cos z, again take second derivative, limit z tends to pi by 2 minus UV formula, z into sin z derivative cos z plus sin z into z derivative 1 cos z derivative minus sin z 1 by 2 limit z tends to pi by 2 minus z cos z minus sin z minus 2 sin z 1 by 2 minus pi by 2 cos pi by 2 2 sin pi by 2 sin pi by 2 is 1 cos pi by 2 0 1 by 2 into minus 2 into 1 so minus 1 by residue theorem into over C f of z dz is equal to 2 pi into SR means sum of the residues into over C z cos z by z minus pi by 2 whole cube dz is equal to 2 pi into sum of the residues minus 1 so minus 2 pi I. Using residue theorem evaluate into over C z secant z by 1 minus z whole square dz where C is a circle mod z is equal to 3. Solution according to given problem f of z is z secant z by 1 minus z whole square poles of f of z 1 minus z whole square is equal to 0 z is equal to 1 mod z is equal to 3 is a circle with center C0 0 and radius r is equal to 3 x dash y dash 0 center 0 0 3 3 minus 3 minus 3 so 1 lies inside the circle 1 lies inside the circle is a pole of order 3 so 3 3 minus 3 minus 3 1 so z is equal to 1 is a pole of order 2 lies inside the circle mod z is equal to 3 residue f of 1 is equal to limit z tends to 1 1 by 2 minus 1 factorial d by dz of z minus 1 whole square f of z result 2 higher order formula result 2 limit z tends to 1 1 factorial is 1 d by dz z minus 1 whole square f of z is z secant z by 1 minus z whole square cancel limit z tends to 1 apply UV formula z into secant z derivative secant z derivative secant z tan z plus secant z into z derivative 1 z derivative 1 secant 1 tan 1 plus secant 1 by residue theorem do over C f of z dz is equal to 2 pi into sum of the residues over c z secant z by 1 minus z whole square dz equal to 2 pi into sum of the residues. This is nothing but secant 1 tan 1 plus secant 1 Problem 53. Using residue theorem, evaluate integral over c e power 2z dz by z plus 2 into z plus 4 into z plus 7 for c as circle mod z is equal to 3. Solution f of z is equal to e power 2z by z plus 2 into z plus 4 to z plus 7. Poles of f of z are given by equating denominator to 0. We get poles z is equal to minus 2, z is equal to minus 4, z is equal to minus 7. Mod z is equal to 3 is a circle with center C0 0 and radius r is equal to 3. Diagram 3 3 minus 3 minus 3 center 0 0 x x dash y y dash. Minus 2 lies inside the circle, minus 4 lies outside the circle, minus 7 lies outside the circle. So z is equal to minus 2 is a pole of order 1 lies inside the circle mod z is equal to 3. Z is equal to minus 4 is a pole of order 1 lies outside the circle mod z is equal to 3. Z is equal to minus 2 is a pole of order 1 lies outside the circle mod z is equal to 3. Residue f of minus 2 is equal to result 1. Use result 1. Limit z tends to minus 2 z plus 2 into f of z. Limit z tends to minus 2 z plus 2 into what is your f of z? Z plus 2 cancel. Instead of z you write minus 2, 2 into minus 2 minus 4, minus 2 plus 4 minus 2 plus 7. E power minus 4 by 2 into 5 10. By residue theorem into over c f of z dz is equal to 2 pi into SR means sum of the residues into over c e power 2z by z plus 2 into z plus 4 into z plus 7 dz is equal to 2 pi into e power minus 4 by 10. 2 cancel. Pi I by 5 e power 4. Problem 54. Using residue theorem, evaluate integral over c z minus 3 by z square plus 2z plus 5 dz, where c is circle, a bit mod z is equal to 1, b bit mod z plus 1 minus I is equal to 2, c bit mod z plus 1 plus I is equal to 2. Solution f of z is equal to z minus 3 by z square plus 2z plus 5. Poles of f of z are given by equating denominator to 0, z plus 1 whole square plus 2 square 0, z plus 1 whole square is equal to minus 4, z plus 1 is equal to plus or minus root minus 4, z is equal to minus 1 plus or minus 2i. So z is equal to minus 1 plus 2i minus 1 minus 2i. So p minus 1 2, real part minus 1, imaginary part I coefficient 2. Q minus 1 minus 2. What is your A bit? A bit mod z is equal to 1 is a circle with the center C 0 0 and radius r is equal to 1. Diagram so x 0 0 x dash y y dash. So minus 1 2 minus 1 2, this is 1 minus 1 1 minus 1 minus 1 2, this is minus 1 2 point minus 1 2 p point. Next q point minus 1 minus 2, this is q point minus 1 minus 2. So lies both points lie outside the circle mod z is equal to 1. Poles p comma q are lie outside the circle mod z is equal to 1 by Cauchy's theorem. Integral value f of over c f of z dz is equal to 0 integral over c z minus 3 by z square plus 2z plus 5 dz is equal to 0. B bit mod z plus 1 minus I is equal to 2 is a circle with the center C minus 1 plus 1. Plus 1 is there, right opposite sign minus 1. Here imaginary part coefficient minus 1, right opposite sign plus 1. C minus 1 1 and radius r is equal to 2. Now consider P point. What is P point? Point P minus 1 2. Find CP. Root over minus 1 minus of minus 1 plus 1 whole square plus 1 minus 2 whole square. Root over 0 plus 1 root 1 1 less than 2 r. CP less than r implies P lies inside the circle mod z plus 1 minus I is equal to 2 and is a pole of order 1. Is a pole of order 1. What is your Q point? -1 -2 CQ root over -1 minus of minus plus 1 whole square plus 1 minus of minus plus 2 whole square 0 plus 3 square 9 is equal to 3 greater than 2 CQ greater than R implies Q lies outside the circle mod z plus 1 minus I is equal to 2. Residue f of -1 plus 2i is equal to limit z tends to -1 plus 2i z minus a form into f of z. Limit z tends to -1 plus 2i z minus a into f of z value. This one cancel other factor. So put z is equal to -1 plus 2i here. Simplifying, we get this one. By residue theorem, into over C f of z dz is equal to 2 pi into SR means sum of the residues into over C z minus 3 by z square plus 2z plus 5 dz is equal to 2 pi I into what the value minus 4 plus 2i by 4i is equal to 2i cancel here pi into minus 4 plus 2i by 2 is equal to pi into minus 2 plus I. C mod z plus 1 plus I is equal to 2. Do homework. Same as above B. Do homework.